Hey, stats people, look who's here. Mr.
Yep.
Lewis is back. The doors are locked. He can't go anywhere.
Yeah, I had to make the return. It was nice to be away. But now let's get back to making a stem and leaf plot.
Cool. This sounds illegal.
Okay, so we look at a set of data, such as the one below, with the amount of time spent surfing the internet, and we might want to make a stem and leaf plot to better give us an understanding of the shape of this distribution. All right, so we already have the weapon of using the histogram, but now we're going to add to that with a stem and leaf
Wait,
plot.
whoa, Lewis. Is this minutes or hours?
I think this is minutes.
90. I think a kid would spend more like 94 hours than 94 minutes. But
Well, this was probably an older data set.
all right,
Probably back
maybe
when,
10 years ago.
probably back when you took 90 minutes to dial in.
I had that.
Okay, so here we have our example. All right, and we want to look first at the stem. Now, since these are all two-digit numbers, okay, the most significant digit will be our tens position. So therefore, we make our stem the tens position, going from 0 all the way through 9.
So wait a minute. We're splitting this up into two pieces: the stem and the leaf.
Correct.
Okay. So since there are two digits, this is easy.
Yes.
All right.
All right. So at 0, we had 0, 7 up here.
Yeah. Can we do the first column?
Yeah, sure.
Okay.
Here we skipped 10, so here we have 2. So 2 and 8 would make 28. 4 and 2 would make 42. 4 and 7.
So put the 7 after the 2.
Yep.
I usually, well, no, that's fine. I was thinking we separate them with commas, but
We could do that. Would you like me to separate it with a comma?
I can't, to be honest, remember now if we separate them with commas. We'll keep going.
All right. 7. Okay, 72, we'll put a 2 there.
Right.
83, put a 3 there. You kind of get
Super.
the idea. And then at the end, we'd make a key. But let's look, after we put in all the data, it would look something like this.
They did have commas.
They did. Well, it's
So
an easier
circle
way to
one of
look
the
at it.
numbers. Circle one of the numbers.
How about that one?
Okay, so what does that represent?
Okay, that would represent 24. So to make our key, I should probably type key. Okay, so we have a 2, then we make a vertical line representing the split between the stem and the leaf. So here's our stem, here's our leaf. We know that equals 24.
Yeah, sometimes the stem might be the hundreds digit and the leaf the tens digit. So this could have easily been 240 or something else. So the key tells us. The key is important.
All right, another way we can resemble is we can flip it so it can kind of look like a histogram. All right, so Mr. Miller, you want to kindly read off all of our numbers?
Sure.
As I remember. I
So-
remember the 7.
7, then for stem 2, it goes 0,
0,
4,
4,
5, 5,
5, 5,
8, 8.
8, 8,
And then the next is 0,
0,
2,
2,
5.
5.
And the next
Nice and
one
short.
is 2, 3, 4, 5, 6,
Am I sensing a pattern?
7, 8, and 8. The next one, 0 and 1.
0 and 1.
I believe there's a gap there.
Gap there. Okay.
And then we have 2, 5,
5,
7, 8,
8,
9.
9,
Then we have 3, 7, 8,
7, 8.
and 3, 4. It is kind of a histogram because you could think of it, the bends being 10 in this case. It's going up by tens. So it is very much like a histogram.
Yeah, or even better, tomorrow when we get to dot plot, it almost looks similar to that as well.
So you can still describe the same way, like shape, center, spread, unusual features. Everything we use to describe histograms, you can use to describe these. Also, wait.
Man, I'm getting jumpy. All right, you
All right.
just keep us on it.
Big advantage. Mr. Lewis, what's the big advantage of this?
The biggest advantage of the
Stem and leaf plot?
stem and leaf plot is to look at distribution numbers. So you can see how many are in the 2 column compared to all the other numbers, same as 4. So in this one we can see it 4 and 2 with the majority of our data in there. It makes it a little easier for us to kind of picture out that where our center would be or our mean.
Yeah. And all the data is still there. So that's very good. Another advantage is all the data is still in the graph. So when we draw a histogram, we lose it. We don't know what the data
is
was
correct.
precisely. But here, all the data is still there and available for us. All right, let's keep going.
Okay. All right. And sometimes we have bigger digits. So here we have 3-digit numbers. All right. Now we were really nice and we made them all the same 100. Okay. Sometimes that's not as good. So you want to choose the most significant number. So since these are all in the 300s, we can move it to just the two. We can go into the 110s position.
Yeah, so if we use just the most significant digit, they'd all be 3. So our stem and leaf plot would be one big row, and we don't want that. We want at least a couple of rows.
Right, so it'd be the same idea. Here we have 34. We put the 5 here. Okay, 58, 59. Separate that with a comma. Here we have 7 and 9. Yeah, and 6, 6. 8 and 0, 9 and 9.
Wonderful. And sometimes they put the rows in order. So we know you could do that. So a really nice stem and leaf plot, each row, the leaves are put in order. But that's not necessary in class.
No, just helps the OCD people out. All right, so our key here, if I just pick the 34, 34, vertical line 5 equals 345. Because like Mr. Lamillo said before, we don't know if that means 34.5, 345, we're not really sure. So got to make it reader friendly.
Okay. Ooh.
Ooh, yeah. All right, different kinds of plots. Here we have 2 data sets that we kind of back to back. It's called a back-to-back stem and leaf plot. That makes sense. Right?
Cool.
All right, and we're comparing cholesterol levels of smokers and non-smokers. Okay, so these are kind of nice when you're sharing the same stems. Okay, you can kind of easily compare two different categories. All right, so here we can see that non-smokers have a much lower LDL rate than the majority of the smokers had.
So the center for non-smokers would be between 12 and 13, right?
Yeah, I would probably
So
even
a typical
push it
value
upwards.
is 12 to 13. That's the stem. So maybe 100, 129 or 130 would be a typical value. We think that the stem is the hundreds and the tens, and the leaves are the ones. So over here, what would we say a typical smoker is?
I'd probably say like 162, 64.
Okay, yeah, somewhere around here where this is concentrated. They both look fairly symmetric.
Yeah, these are kind of nice.
And
This one's a little more right skewed than this one's more centered.
spread almost seems the same. The big difference is the center. Yeah, the one on the right is a little skewed to the right, but big difference is center in this case. Okay.
All right. All right, and then the last kind of stem we're going to look at, we're going to look at these a little more even. Well, actually, we'll look at the back-to-back a little more tomorrow. But here we have a split stem. All right, so sometimes we're sitting here and we're looking, we have very few stems, but our leaves aren't going to tell us much. So then we want a little more kind of specificity, I should say. And we split them up. Here we have, less than 5. So here we have 0 to 4 and 5 to 9.
So here, every row is just getting split into 2 rows, and all the values that are between 0 and 4 will go in the first row, and then all the values 5 to 9 go in the second row. So each of the original rows split into 2. You can split them several ways. You can split them into 5s.
Yeah, there's no real system. Usually splitting it around 5 is the most common way, but it kind of also depends on your data.
Yeah, and the idea is to be able to see the graph or the characteristics of the graph better. Okay.
All right. So what time is it?
McDonald's time.
It's not McDonald's time. McDonald's is awful. Don't ever eat that.
How about McFlurry's?
All right, so it's your journal question time.
It always ends in the journal.
The following data represents the number of fat in grams in breakfast meals offered at McDonald's. So you can see here are our fat grams, all lined up nice and neatly for you. Okay, so your idea is to construct a stem and leaf plot and then describe the shape of the distribution as well as center and spread. So we've kind of looked at our histogram shapes. You apply that same kind of concept to the stem and leaf plot.
Right. Remember, center is a typical value. We'll get more specific soon, but for right now, just think where is the distribution concentrated most? And the spread, just give us 2 values between which most of the other values lie. Okay?
All right.
All right, good luck.
Sounds good.